Good morning, everyone. Maya, good morning. I'm sharing the link to everyone. Jotam, you also online today attending? Okay, we'll start the class. Jotam, Ashish, Maya, Kavya, good morning, beta. Come on, join as fast as possible. Today we are going to study numericals and we have lots of work today. Okay, so refractive index we have understood, optical density we have understood. All the term, good morning, beta. Very Sai. So all important sections related to our that section we have understood, and we have also okay, we have also understood that refractive index depends upon what and all factors, okay, like optical density. Today, I'm going to teach you some very important points. Sophie, good morning. Good morning, beta. So, refractive index definition. What is the definition of refractive index? So, the first important point, yes, I'm seeing Dhanushya, good morning, beta. Satya, good morning. Everyone, please be live. Now, listen. So, the ratio between sine of angle of incidence, the ratio between the sine of angle of incidence. Let's check this one out. Porani, good morning. Anu, good morning. Sharmila, good morning. The ratio between sine of angle of incidence. Come on, check this one out. Better numericals we will do today. Sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant, and this is exactly called as refractive index. What it is called as? Refractive index. The ratio between sine of angle of incidence and sine of angle of incidence. Come on, the ratio between the sine of angle of incidence and the sine of angle of refraction. Savna, good morning. And sine of angle of refraction is exactly considered as what, beta? Refractive index. So incidence by refraction is considered as refractive index, and refractive index is usually denoted by how, beta? We can denote it by this symbol, okay? And then here Anusha, good morning, beta. So now, good morning, Anusha. Now look here, beta. So here, refractive index is usually denoted by this symbol, and here either you can write 1, 2 like this, or you can write like this 1, 2, like both the side. But beta, because it is representing two mediums. How many mediums it is representing? Two mediums. It is representing two medium, means the light is traveling from one medium to the other medium. Understood? The light is traveling from one medium to the other medium. This is actually representing this. This is actually representing this. Now, without wasting time, I want to take you to numericals. Okay, simple things are there, but one question is there, that is CBSE question. If you will listen me very carefully, please kindly answer my one question, that the extent. See, we know that when the light is traveling, Divya, good morning, beta. When the light is traveling from, listen very carefully, children, when the light is traveling from a rarer medium to a denser medium, and denser medium to a rarer medium, at that time something happens. That is what? The speed slows down or the speed increases. So I'm going to talk about the speed slowing down. Understood? So when the speed is slowing down, what is the factor behind the slowdown of the speed? What is the factor behind the slowdown of the speed? What is the factor behind the slowdown of the speed? All the children, you need to keep on answering my question. Only I will be saying, taking your attendance based on that only. Optical density. Kavya is telling optical density, beta. what you are saying? What is the reason behind the slowdown of the speed? Come on, everyone. See, you must check that your live button is on red color. Then only it is exactly your answer will be meeting me, means reaching me in perfect time. What is that? That is optical density. Kavya has given the answer, but there is two answers here. Can you tell me the second answer, please? So the extent of slowing down, right? The extent of slowing down of the speed of light, the extent of slowing down of the speed of light depends upon two factors. Means how much the speed of light will slow down, it depends upon two factors. Okay. The extent of speed of light, the extent of speed of light or slowing down of light depends upon two factors. Slowing down of light depends upon how many factors? Two factors. It depends upon two factors. Yes, it depends upon two factors. The first factor is optical density. The first factor, everyone keep answering the question, keep typing. If you will not type means I will assume that you are sleeping. Now, first is optical density and second one is color or wavelength of light. First is optical density, note down. First is optical density and the second one is speed or the color or wavelength of the light. The color or wavelength of the light. The color or wavelength of the light. Okay, the color or wavelength of the light. So optical density, wavelength of the light. Better keep on answering the questions, please. Keep on answering the questions. The color or wavelength of the light. Similar optical density, wavelength of the line, no. Color or wavelength of the light. Color or wavelength of the light. So these are the two things on which the how much extent the speed will slow down depends. Okay, how much extent the speed slow down for what you call going from one medium to another medium depends. Beta, this is one of the most important thing. Okay. Now we have to understand. So refractive index always we understood. Good morning, beta. Good morning, Shakti. So now look here, beta. So optical density and wavelength of medium. Yes, means wavelength of light going from one medium to another medium. Wavelength of light going from one medium to another medium, beta. That is the most important thing. Now we have to understand what is the meaning of absolute refractive index. Children, anyone who can say me absolute refractive index? Anyone? We know that sin I by sin r is there. We are writing about sin I by sin r. So look here, sin I by sin r is equal to constant. That is the formula of refractive index and I am going to explain you. So if light will be traveling from one medium towards the other medium. So one part we are going to do just here. When the light is traveling from one medium to another medium, beta, then what time what we are supposed to write here, just one small thing I'm doing because we have to start numericals, time is not there. So what we are going to write, we are going to symbolize it as NAG. What is this means? Light is exactly traveling from air to glass. Understood? So velocity will be changing according to that, optical density and wavelength. So velocity will be changing according to that, beta. So we are going to write sin I by sin r. This sin I by sin r is for what, beta? Going from air to glass. Going from air to glass. But beta, if somebody will be writing, this one G to A, so what you are going to write about it? What you are going to understand about it? Glass to air. Understood? So that time it will become, so here sin R by sin I can I write? Correct na? Sin R by sin I. I am writing like that so that you can understand. So when the ray will be traveling from first case is what, beta? First case is when we are checking it, first case is air to glass, second case is glass to air. Okay. First case is what, beta? Air to glass, second case is glass to air. Now beta, what we can do here is, shall we multiply them together? shall we multiply together? In simple format, we can multiply together, correct na? So when we are multiplying both of them together, what we are getting? NAG, that means the light traveling from air to glass, and then beta it is traveling from glass to air, is equal to sine I by sine R into sine R by sine I. So beta sine R and this will get cancelled. This will get cancelled beta. So what we are seeing here is NAG into NGA is equal to 1. So the value of refractive index when it will be coming, so sin I by sin R whenever you are writing beta, so there it will be absolute. So only it is considered as absolute refractive index, and for absolute refractive index, one of the medium we are taking it as air. Now one of the medium we are taking it as air. Now another important point to be noted here. So beta when we are writing like this, so one more content we can write that this will be reciprocal of this. Means when you are going from, yes beta, when you are going from one medium to another, means air to glass will be equal to reciprocal of glass to air. That is one of the derivation. Air to glass will be reciprocal of glass to air. This is one content we need to understand beta. Now every other material is having a different refractive index. Okay, every other material will have a different refractive index. Note down this one beta. Every other material will have a different refractive index. Come on, check this one beta. Note down air to glass, glass to air, air to glass beta, and glass to air. Come on, check this one out. Air to glass, air to glass, and glass to air. So did you note it beta? Did you note this? Air to glass and glass to air. If we have done till here beta, just press the live button so that you can be answering my question to the point. Okay, so to the time, to the point, and the correct pace. Okay, now look here beta, air to glass and glass to air. This is one important thing. I hope you might have understood this one because we have to go to the second section. So let's start the next one beta. Shall we start the next part beta? Are we ready? Children, are we ready for the next section? Now, beta, this is exactly one part we have learned. And sin I, sine of angle of incidence, and sine of angle of refraction. Okay. Please note that since that refractive index is ratio of two similar quantities, so it has no unit. That part also I have discussed that it is having no unit. Now, beta, without wasting time, we are going to solve some questions. Okay. Now, I am giving you some comparison. You need to answer my question. Children, I'm giving you some comparison. You need to answer some of my questions. So now just let's check this one out. Okay. Now I'm giving you some values. You need to check and tell. So the refractive index of benzene, that is N. The refractive index of benzene is 1.50. Okay. And the refractive index of alcohol, the refractive index of alcohol is 1.36. Can you tell me among them whose optical density, wait 1 minute, I think it is coming blur. Can you tell me among them whose optical density is highest? Benzene and alcohol. So refractive index of benzene is 1.50. Refractive index of alcohol is 1.36. Type and send me fast. Benzene for B, alcohol for A. Whose refractive index is highest? Benzene. Benzene refractive index is highest. So whose optical density is maximum? Whose optical density is maximum? Come on, everyone, press the live button and then start answering. That time answer will come to the very fast. Yes. So answer is yes, absolutely correct. The correct answer is benzene. So if higher refractive index, yes, absolutely correct. So higher refractive index means, Sophie, your answer is not coming. Sophie, your answer is not coming. Korani, your answer is not coming. So beta, that means what? Refractive index is, yes, the refractive index is exactly coming as what beta? The refractive index of benzene is maximum because its optical density is higher. Naitik Verma, answer is A beta. Absolutely. A is here alcohol na beta. Alcohol refractive index. Can you compare the refractive index of Naitik? Here you see it is 1.50 beta and here it is 1.36. So refractive index of benzene is higher. That means what? Its optical density is more. Its optical density is more Naitik. Like that we can take. Okay. Higher refractive index means, okay beta, so now we will go for the next one. Come on, we will start solving one question, but before solving a question, okay, water refractive index is 1.33. Refractive index is 1.33 and ice refractive index is 1.31. Slightly varying. Okay, children, slight variation is there. Slight variation is there. Water and ice. Now, whose optical density is on a higher side? Water or ice, whose optical density is on a higher side beta? Can anybody tell whose optical density is on a higher side? Come on children, you can answer. Optical density is on a higher side. Higher side I am asking, Maha. Optical density is on a higher side. Sophie, absolutely beta, because if you see it is coming as 1.33. Very good, super. It is coming as 1.33 beta. So 1.33 when it is coming, 1.33 when it is coming means here you need to understand that the optical density of water is more than optical density of ice. Absolutely. Now keep on answering, keep on answering. Now next one, kerosene and water. Kerosene and water. Kerosene and water. Can you compare between kerosene and water? Kerosene is 1 point. Kerosene. Come on, note down kerosene because I am going to kerosene. Very good, beta. But one thing we need to understand here, beta. Natik. Here now one part is there. One part is there. Whose density is more? Whose density is more? The density of whose is more? See, here, very good. Water density is more or kerosene density is more? Who is more denser? Water or kerosene? Yes. So optical density, I'm not talking about density is equal to mass by volume. So here if density is equal to mass by volume we will take, then it will be different. Okay. So optical density of kerosene is more, because of that it's what you called refractive index is also high. Its refractive index is also high. Children, you have given a very correct answer. Understood? So optical density of kerosene is more. Understood? But density, if you will be checking beta, if somebody will be asking density, then you will say density of water is more than kerosene. It is lighter. But one thing is there that the optical density of kerosene is higher, because of that its refractive index is more. Its refractive index is more. Now beta, we are going to write the first numerical. One simple numerical I am writing. Everyone solve it and say me the answer. Okay. Ready? First numerical I am writing. Okay. It has been found that it has been found that come on, check this one out beta. It has been found that the array of light while while traveling from air to glass Okay, from air to glass, the light is exactly traveling from where to where? Air to glass, has angle of incidence, has angle of incidence, has angle of incidence. Come on, go for it, beta. Angle of incidence 47 degree, 45 degree, and angle of refraction as 28 degrees. And angle of refraction as 28 degrees. Okay, angle of refraction is how much, beta? Angle of Ayush. Good morning, Ayush. So angle of refraction is 28 degree. You need to find the refractive index. So you need to find the refractive index. Find the refractive index. Find the refractive index. So now, beta, if somebody will tell you to find the refractive index, Ayush, good morning. So now, first is sine 45 degree and sine 28 degrees. So sine 28, sine 20, Manju, good morning. So sine 28 degree, late beta today, sine 28 degrees. Come on, tell me the values. It is, they have given that 4696. Okay, 4696. Okay, and here they have given sine 45 degree, sine 45 degree, and it is given as 0.7071. Got it, beta? 0.7071. So now we have to solve this question. Come on, children, try this one out. First, little bit I am drawing so that you will understand this. So the ray of light is traveling from where to where, beta? The ray of light is traveling from air to glass. So this is angle of incidence, and this angle is exactly I, and I is coming as 45 degree. Okay, so medium 1 is considered as 45 degree. Come on, check beta here. So this is exactly air, and here, and then it will bend towards the normal. It will bend towards the normal. This is R, and R is coming as 28 degrees, and this is exactly coming as glass. So refractive index of air, see angle subtended given, angle subtended, children listen very carefully, angle subtended, incident and refraction is given. Now we have to just use Snell's law. So what is our Snell's law, beta? So refractive index, if somebody will be telling you, so already all values are given, sine I by sine R, refractive index. Come on, give me the value, beta. Give me the value. Take out the value and give me. All the children, those who are so here, the light is exactly traveling from air to glass. Air to glass. So refractive index is 1.50. Means air to glass it is going. The refractive index is coming as 1.50. Kavya has given the answer. Come on, children. Others, please give me the answer. Very fast, try to answer the question. Live button press. You will be coming. So here sine I. So what is our sine? 45 degree. And here beta sine R. Sine R is exactly 28 degrees. So here I am writing 28 degrees. Sine I and sine R. 45 degree. Sine I by sine R is constant. Absolutely correct beta. Sine I by sine R is constant. And usme na value put karo now. So here what is the value beta? Sine 45 degree value is what? 0.7071 given, 0.7071, and here it is, the value given is how much beta? 0.4696. now इनको cancel करेंगे, how much it is coming? 7071 by 4696. Okay, so approximated value beta 1.5. Yes, absolutely. मंजू 1 by root 2 का वैल्यू जब निकालेंगे बेटा तो 1.5 आएगा. Absolutely correct बेटा. सी 1 by root 2 जब डालेंगे तो root 2 का वैल्यू 1.414 होगा बेटा. 1.4 by 4 1.414 होगा. ठीक है. When we will solve, the answer is coming as 1.5. So what is the refractive index coming beta? The refractive index is coming as 1.50. 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 Shall we go for the next question? अब इस क्वेश्चन का क्या जवाब दो बताओ. Beta, are we ready for the next question? Children, are you all ready for the next question? So write next question. I can only say God bless you and thank you. Now beta, we'll go for the next one. Is it done? Is it done? Now we will go for the next one. The refractive index of a material is 1.4. Okay. So the refractive index of a material is 1.4. Okay, beta. The refractive index of a material is the refractive index of a material. पढ़ाई करेगा unknown. The refractive index of a material is 1.4 if velocity of light in vacuum. So, beta, velocity of light. If velocity of light in vacuum, beta, start writing the answer. If velocity of light in vacuum, if velocity of light in vacuum is 3 into 10 to the power 8 meter per second, velocity of light in vacuum is velocity of light. पहले पढ़ लेते हैं, बोर्ड एग्जाम दे दे, उसके बाद बात करेंगे. So now look here. If velocity of light, क्वेश्चन में फोकस करो. If velocity of light in vacuum is 3 into 10 to the power 8 meter per second, find the velocity of light in the material. Find the velocity of light. Write the answer, beta. Find the velocity of light in the medium. Find the velocity of light in the medium. Find the velocity of light in the medium. Okay, chalo solve karo isko. What is the formula for this? What is the formula, beta? For this, we are writing a formula: velocity of light in vacuum by velocity of light in medium or material. Okay, velocity of light in vacuum or velocity of light in material. Come on, we'll do it. Velocity of light in medium or by velocity of light in material. Come on, come on, come on. We can write like this and we can solve. Come on, go for it. What is the formula, beta? This n is equal to what we will write? Velocity of light in vacuum by velocity of light in material. Velocity of light in material. Okay, so now here already refractive index is given. The refractive index is exactly coming how much, beta? The index of a material is 1.4. So refractive index is given to you. Velocity of light in vacuum, velocity of light in material. Absolutely correct, beta. अब उसमें formula डालो. So here it is refractive index is coming as how much, beta? Refractive index given is already 1.4. Okay. Now velocity of light in vacuum is what? 3 into 10 to the power 8 meter per second. Now what we need to find is velocity of light in material. Very good. So velocity, say here beta. Velocity of velocity of light in material. Velocity of light in material. Okay. अब इसको उधर शिफ्ट कर देते हैं. We will shuffle this. This will go down and this will come up. Okay. So here velocity of light in material. Velocity of light in material. Anyone who solved and gave the answer, please give the answer. In material, velocity of light in material is equal to, now 3 into 10 to the power 8. Down is coming as beta 1.4. Okay, 1.4. 1.4. 1.4, 1.4 is going to divide 3 into 10 to the power 8 meter per second will be divided by 1.4, beta. It will be divided by 1.4. एक बार check करो. Okay, so divided by 1.4. So velocity in material is what beta? 3 by, we will be writing it like this, na? So 3. So if this decimal will go, it will come as what beta? 10 will go up. So now it is coming 30 into 10 to the power 8 by 14. Okay, 13 into 10 to the power 8 by 14, just ऐसे लिखा मैंने. Okay, अब now try to solve it beta. So here 30, so 2 sevens are and here 15 आया. ठीक है, अब देखो 15 से 7 को 7 टू ज़ा 14 1.0 7 1 ज़ा 7 30. सो बेटा क्या हम इसको ऐसे लिख सकते हैं 2 पॉइंट बिकॉज 28 इज कमिंग एज 2. now here it is coming as 20, so again 2 points, so we will write 2.142 into 10 to the power 8 meter per second. So what is the velocity of light in medium? 2.14. Good morning, Rishabh. How are you, beta? Late. 2.142 into 10 to the power 8. 2.142 into 10 to the power 8. Children, what is the final answer? 2.142. So that means what? By seeing the refractive index in the medium, what in all observations you have done? Come on, answer the question. Let's do something extra. By seeing the refractive index of the medium or the material, what in all conclusion we have drawn? We have drawn the conclusion beta, here speed of light in material is lesser than the speed of light in air. That means 100% we fall into one conclusion that yes, absolutely correct, unknown, and Hari, Shakti, absolutely correct. Kavya, absolutely correct. Maha, absolutely correct. Very good, beta. So here, when we are writing this, beta, we are coming into one conclusion, and that conclusion is yes, Anu, absolutely correct. That refractive index is higher, means optical density. So material is having higher optical density than air. Got it? Because the speed of light got deteriorated when it is going from air to that material. Understood? So this is our conclusion also. So by accidentally also, if somebody will ask you your conclusion, you must be ready to answer, beta. Are you ready for the next question, beta? Now let's see. The next question is, come on, write down this question. A light of, write down, a light of wavelength 500 nanometer, a light of wavelength, a light of wavelength 500 nm, in short I am saying, (500 nm) in air enters a glass block, in air enters a glass block, in air enters a glass block, okay, of refractive index, of refractive index, of refractive index. Come on, check this one out, beta. See, if you are not live means you need to come live as fast as. Yes, but I'm teaching grade 12 students also. So, glass block of refractive index 1.5 is there. Now, beta, you have to find first speed. Second one, beta, you have to find speed, and second one frequency. And third one is wavelength. So if somebody will ask you these questions, what answer? And third is wavelength. Okay, wavelength of light in glass. Logi. If they will ask like this, what and all work we are going to do? Come on, answer the question, beta. Come on, answer the question. चलो शुरू हो जाओ. Try, beta. See, if they will give you like this to irritate you, you also irritate them. Okay, you also irritate them because with a velocity of light in air, how much given? 500 nm. That is directly you write 500 nm means 3 into 10 to the power 8 meter per second only. Okay, that's what Rishabh, absolutely correct beta. So if they will be asking, yes, the speed of light in air will be that only. Now, why we are going to write here and there? Absolutely correct, Rishabh. That's a very good prediction. So here you need to understand this part. So if somebody will be asking you this question and they will say that speed. So now look here, what happened? Patel, अंशुमान. Now look here बेटा, first is क्या मजाक नहीं आ रहा है. Good morning, Ayan. Good morning, beta. So now look here. Please understand this one. We are studying. So beta, at the time of study, we must study. And at the time of eating, we are eating. So at the time of study, we must study. We are here for some good things. So let's do that work, learn, and let others learn. Okay. हाँ ये सही बोला. ठीक है. So now look here beta. So that's your prediction. But let's see. A light of wavelength 500 nanometer is there. So whenever you will be converting it directly, we can say 500 nanometer means 3 into 10 to the power 8. Thank you so much beta. 3 into 10 to the power 8 meter per second. So exactly how much it is coming beta? 3 into 10 to the power 8 meter per second. So now refractive index, when somebody will be asking, what we can say beta? The refractive index from air to glass we are writing. So refractive index from air to glass, what will be there? Velocity of light in air by velocity of light in glass. Directly formula we will write. So we will write velocity of light in air by velocity of light in glass. So directly now refractive index they have not given, but velocity we have exactly checked. This is exactly given. So now can you tell me the next part what we can do? 1.5 it is exactly given. Glass we know that. Okay. So here we are going to write the content and solve it. Yes, velocity of light in air by velocity of light in glass. So exactly we have written already, we have already known that it is coming as 1.5 beta. Refractive index is given. In the question, refractive index is already 1.5 given. I missed it because of one very nice person, I missed it. So exactly refractive index is given 1.5. So glass refractive index is given as 1.5. Ayan, understand karo beta. See, what is given in the question, first to understand. They told that speed of light in air is 500 nanometer. So, nanometer को convert किया हमने. What we are getting it? We are getting the speed 2.99 आएगा यार. So, 2.99 into 10 to the power 8 meter per second will come what beta? This will come the velocity of light. Okay. So, a light of this wavelength in air enters a glass block. So that means one glass block is there. In this glass block, this is normal. So the light is entering with a velocity of 3 into 10 to the power 8 meter per second. Here they have given velocity. They did not mention the angle. Okay. Here sin I by sin r we cannot take. Here we will take velocity. Here sin I by sin r we can't take. Here we can take velocity. So with what velocity it is coming from air to another medium? Rishabh, answer is coming as frequency. Answer you have given. Let's check me. Let me check that frequency section beta. Just frequency 500 nanometer. Now we are going to use that. Don't worry. So now here, so velocity of light in air when we are talking about 3 to 10 to the power. And beta, what will be the refractive index in glass? The refractive index in glass is 1.5. So directly we can write like that beta. So once we are writing this, 1.5 is equal to 3 into 10 to the power 8 meter per second. So velocity will come to know, we'll come to know what is the velocity of light in glass. Come on, first find the velocity of light in glass. After that beta, we will do some other work. So velocity of light in glass. Now come on, go for it beta. We will shift this one. It will come velocity of light in glass is equal to 3 into 10 to the power 8 by 1.5. Come on, cancel this. It will come 10 and here it will come 5 and here 2. So the correct answer is 2 into 10 to the power 2 into 10 to the power 8 meter per second. So velocity of light in glass. Everyone, come on, check this one out. Come on, check this one out. Everyone, just say hi to me. I'll come to know how many of you are present there right now. Yes, beta. Velocity of light in air by velocity of light in glass. Unknown, absolutely correct, beta. जरा सा इसको इस पे ध्यान दो. Unknown, yes, hi unknown. I'm listening. I'm reading your comments also. So velocity of light in glass is coming as 2 into 10 to the power 8 meter per second. So once this has come, velocity of light is exactly coming. Yes, 2 into 10 to the power 8 meter per second. This is velocity of light in glass, beta. Now they are asking about frequency. What they are asking about? Frequency they are asking about. Very good, Shakti. Anu, three of you have given the answer. I'm waiting for others' answer. Jotam, all people, where are you all? Come on, answer the question as fast as possible. So if they will say that, if they will ask what is the change in the frequency, can anybody talk about frequency formula? Beta first तो frequency formula मैं दे रही हूँ. Okay, frequency. So what happened? Okay. I am in live class. Thank you, beta. Class over or class started now? Still no did not came. Why? Okay, I'll check. Now, beta, first we'll write the formula. Frequency formula. I'm giving frequency formula, beta. But before giving frequency formula, let's check this one out, beta. Before giving frequency formula, see, first thing is frequency of light does not depends upon optical density. Okay. So change in frequency, somebody will be asking you now. So Tarun, answer is correct, beta. So frequency of light depends upon what, beta? Is it depending upon optical density of medium? No. So frequency of light is exactly independent of optical density. First to write down this formula, speed of light, unknown, take this formula, speed of light is equal to wavelength into frequency. Okay, speed of light, you can write it as V. I'm moving. Speed of light is taken as V is equal to frequency, wavelength into frequency. This symbol is exactly what, beta? This is called as wavelength. Okay, and this one is coming as frequency. And this V is speed of light. Done, beta? So all the three are there. Yes, all the three are there. Okay. Now look here, beta. Formula दे दिया. अब ये बताओ. They are asking what is the change in frequency. What you can perceive for the change in frequency, बच्चा? Come on, answer this question. Tell me, what can be the change in frequency? See, look here. I'm just giving you a very important thing. Optical density, frequency is independent of optical density. Refractive index is a game of optical density and wavelength. So you need to understand here. Okay. So frequency of wave does not change with change in optical medium. This you always remember and note down, everyone. Frequency of wave frequency of wave, just note down this one, beta. Frequency of wave does not change Sarvana, hi. Frequency of wave does not change. Remember, frequency of wave does not change with change in optical medium. Frequency of wave does not change with change in optical medium. Understood, beta? So if any optical medium change is there, its frequency does not change, it remains the same. So frequency remains the same. Frequency remains the same. Does not change with change in optical medium. Yes, beta, it remains the same. Now wavelength nikalte hain because we have seen change in velocity. We have seen change in velocity. We came to know that frequency remains the same when the light ray is entering from air to glass. Okay. Now we need to find the wavelength. How much is change in wavelength? And we have formula also. Come on children, can you do can you solve this question? Because wavelength was given in how much beta? Wavelength was given in 500 nanometer. Okay. So here wavelength part we are exactly going to. So speed, see, light wavelength will be given. What light wavelength in nanometer is given. And here velocity is already fixed, and that is 3 into 10 to the power 8 meter per second. So light velocity is 3 into 10 to the power 8 meter per second. That is wavelength is 500 nanometer, but velocity is exactly fixed, and that is 3 into 10 to the power 8 meter per second. So now directly we are going to go for the final approach. So what should be our final approach, beta? Can we go for the final approach, please? The final approach is our formula. What is our formula, beta? Can you tell me what is our formula right now? I have given you formula for speed of light in air. Okay, speed of light in air will be what? And speed of light in glass. Frequency remains the same. You remember this. Frequency remains the same. So speed of light in air, speed of light in air will be exactly v, speed of light in air. And understood, beta? So here frequency of light in air, okay, frequency of light in air into its wavelength of light in air. This is speed of light in air. So I am writing VAIR so that you can understand better. Now speed of light in glass. So what we can see here, speed of light in air is 3 into 10 to the power 8 meter per second, and frequency is exactly what, beta? Frequency is, we don't know the frequency. We will write frequency as air into, they have given wavelength as 500 nanometer. That's what I told now, that wavelength, and wavelength is 500, that will be equivalent to 3 into 10 to the power 8 meter per second. Okay, because speed of light. Now here we are going to talk about speed of light in glass is equal to frequency in glass, frequency of light in glass into, we don't know the wavelength of glass, and that's what we need to find. Okay, so wavelength of light in glass we don't know, and that's what we have to find. So wavelength of light in glass, wavelength of light in glass. So beta, this part I am just removing. So here what is the speed of light in glass is 2 into 10 to the power 8 meter per second, speed of light in glass just now we defined. And then here beta, what it will be coming? Frequency of light in glass into wavelength of light in glass. Now beta, this is taken as equation 1 and this is taken as equation 2. Come on children, we will divide equation 1 by equation 2. Trust me, we can do it. We will divide equation 1 by equation 2. Okay. So now beta, we will divide equation 1 by, so dividing equation 1 by equation 2, dividing equation 1 by equation 2. So what will happen beta? Speed is given 3 into 10 to the power 8. So our content was speed of air, light in air by speed of light in glass is equal to frequency of light in air into wavelength of light in air by frequency of light in glass into wavelength of light in glass. But till here, is it crystal clear? Because I just wrote the formulas precisely. Okay. Now we know that frequency does not change. So frequency of light in air will be equal to frequency of light in glass because it is not at all changing. So this will get cancelled. Now we will substitute the formula 3 into 10 to the power 8 by 2 into 10 to the power 8 is equal to, here it is given 500 nanometer. Now we have to find velocity of light in, wavelength of light in glass. So just last part here you need to do, this and this will get cancelled. Now it will go wavelength in glass is equal to 500 into 2 by 3. that is 1000 by 3. 1000 by 3 beta. So it will come how much? We already know 333. So 100% will come 3333 nanometer. So 333.33 nanometer, absolutely correct unknown. So please kindly see, I may don't know how to teach. So what that person told, please you understand this. This is exactly the way of writing. With the formula, you can be able to write. So what we learned first, we are going to recheck. We learned that frequency of light in medium will not change. It remains the same, first thing. Second is because it is independent of optical density. That's it. So that's the first part we learned. Then we learned the velocity formula. Velocity of light is equal to frequency into its wavelength. That formula we learned. Unknown, this is the formula beta. Absolutely correct, Shakti. And after that beta, next part what we learned, we have generated, just we generated a relation because wavelength has been given, wavelength of light in air has been given as 3 into 10 to the power 8, and I told that time that the velocity of light is 3 into 10 to the power 8 meter per second, wavelength is that, and velocity is that, it is not changing, it is same. So that's what I have written and I have explained that. Is it okay for all of you? Come on, say beta. Come on, say, did you understood this part? Yes, beta, super. So it was not a very tough question. It was not a very tough question. Okay, beta. So this is exactly, if you know anything, you will be 100% able. What about the other children, those who have exactly attended the class? Where are they? I'm not getting any answer from them. Now we will be going for some little bit tougher question side. Okay. Ready, beta? Everyone ready? Children ready? Just say me that yes, auntie, we are ready. Okay, then we will go for the next question. Maya ready? Everybody ready? Just keep checking that you are live. Okay, some children. Sufe, good morning, Sufe. Mom is there or you are there? Who is there? Come on. Satya, ready, beta? Now let's see. Next question we are going to do, because one more class of refractive index where higher top sides we are going to solve. I will keep and then we will go for the next section. Right now we are dealing with refractive index. We learned many things about refractive index. Okay. So right, beta, the light of wavelength 6000 Armstrong. 6000 angstrom. Okay, 6000 Armstrong is given. The moment it will be given that much, we are going to check. Okay, so here study. Hello beta, naam to rakh lo re. So 6000 Armstrong in air enters the medium of refractive index. But a medium of refractive index is given as 1.5. Okay, चलो इसी से पता चल जाएगा. Refractive index 1.5 means where, what material? Right now only. What will be the frequency of the medium? What will be the frequency of the medium? Such a cute question. Why we use wavelength? बिना wavelength के क्या होगा बताओ बेटा? Wavelength is what? Just understand the distance between two consecutive crest and trough. okay, of any wave is wavelength. Okay, so wavelength is exactly defining a range. जैसे विजिबल लाइट का एक रेंज होता है, तो हर कलर का एक वेवलेंथ होता है. ठीक है, जब कलर को डिफाइन करना होगा, when we need to define color, it will be defined in a specific wavelength. For only one I have said. 1.5 benzene. They did not ask this, Kavya. Beating you. Wait. They did not ask this. We are not going to go do that only. Remind me of our old days. Yes. Correct. So now just start solving. स्टार्ट सॉल्विंग. चलो देवेंद्र तुम भी सॉल्व कर ही लो. सो फॉर्मूला क्या है? सो बेटा फर्स्ट तो वी विल चेंज दिस वन. हाँ, वेवलेंथ इज गिवन बेटा. सो वंस वेवलेंथ इज गिवन, we will do one thing. Wavelength is equal to 6000 angstrom. It will convert it into meter. So first we will convert it into meter. Can we do it beta? So here we know that 6000 into 10 to the power minus 10 meter. So 1 angstrom is equal to 10 to the power minus 10 meter. Okay, so we got it. We got it. So now this will come how much beta? 1, 2, 3 zeros will go. It will become 6.0. Standard format of writing 6.0 into 10 to the power minus 10 plus 3 meter. So it will become 6.0 into 10 to the power minus 7 meter. So beta, when we will go that side, it will be exactly beta, it will be coming as minus 7. Coming now, check this one out beta. So once you have written like that, we will go for the next part. Okay, now here we have to use our formula. So let's check and use our formula beta. So wavelength we got. So after getting wavelength, now we need to find the frequency. Velocity of light already I have discussed. Velocity of light is 3 into 10 to the power 8 meter per second. By Devendra. So now look here. So we know that one formula, velocity is equal to, just now we saw velocity is equal to frequency into wavelength. Correct na beta? So here we know that this in air is 10 to the power 8. 3 into 10 to the power 8 can we take? And here it is exactly frequency we don't know. And this part is coming in 6 into 10 to the power minus 7. So now just let it multiply. Let it multiply. Come on, check. Is it going to multiply? Because they asked frequency. They asked frequency. Come on, anyone say the answer? Yes, Kritika, 5 into 10 to the power, how much it is coming, beta? Come on, say. Frequency we need to find now. So here it is exactly 3 into 10 to the power 8. Just kidding. Here it will come 6 into 10 to the power minus 7. You are absolutely correct, beta. This is exactly coming. Now we will be only solving it. So here it is coming as 2. Now 1 by 2 into 10 to the power 8 plus 7. Correct? So it is coming as 0.5 into 10 to the power 15. Now here it will become 5 into 10 to the power 14 hertz, because the unit of frequency is hertz. The unit of frequency is hertz. Just check this one out beta. Unit of frequency is hertz. Check this part out. It will not be multiplied. That time I was just okay. So it will not be multiplied. So frequency beta, it will come down of this now. It will come down of this. So frequency will be equal to 3 and 6 will be cutting. It will go up 15. Now what I did is, if you 15 means 10 will be there now. So if you will go one step here, then this will be reduced by 1. So 15 will be 10 to the power 15 will be reduced by 1, because one step you have went right. Whenever you will go one step right, it will be doing like that only. I hope everybody might have understood. So one more session of full numericals are left. Okay, this is one session of numerical where we have discussed. One more session of numerical is left where we are going to discuss the remaining part of the numericals, because refractive index numerical like this only, glass numerical and mirror numerical, one more time we will write. Okay, we will do it. So bye for now everyone. Are you, did you understood how was the class? You learned or not? Say, we did very simple refractive index related questions. We did not did very big things, okay? But we wrote everything nicely. Sufi, good morning. That time I asked you, you did not answer me. Wait. Say your mummy to call me. Bye, beta.